All right, so my last video got cut off at 5 minutes, so this is just kind of a wrapping up of the intro for 12.1. The other piece of vocab that we needed to discuss were sectors, and a sector is just a part of a circle. You can kind of think of it as like a slice of pie taken out of the circle. So if you have a couple of radii with an angle inside of a circle, that slice of pie is called a sector, and that is going to be subtended by the arc length L. So as long as you have two radii and then some arc from a circle, that's going to create those three parts are going to create a circle or a sector. Excuse me. So the area we're going to talk about the area of the sector. That's the last formula that you're going to need for 12.1. The area of that is going to be proportional to the arc length. So all we have to do is take that proportion of the arc length, whatever that angle theta is, divided by 2 pi, and multiply that by the area of a full circle. You don't need to worry about this too much right here. This is just taking the proportion of the arc angle and multiplying that to get the same percentage of the area of the circle. So that all simplifies down. You can see some stuff cancels out. You wind up with this formula for the area of a sector, theta times r squared over 2. And again, for both of these formulas, if we go back and look at the arc length formula, this one here, this angle must be in radians in order to work. Same thing for the area of a sector formula here. For both of them, those only work if you are using radian units. If you have an angle in degrees, you must convert it first. So the final note before we look at a couple of examples here is how to convert from an angle that's in degrees into radians or vice versa if you need it the other way. So we already discussed briefly that 360 degrees is the same as 2 pi. And so we can simplify this ratio just a bit. 180 degrees is equivalent to pi radians, and we can just isolate one of those and turn it into a conversion factor. So to convert from degrees to radians, we can just multiply by pi over 180. Or if you have an angle in radians and you want degrees, you can multiply it by the reciprocal of that, 180 over pi, and that'll give you the result that you want.